Welcome to the Alpha Training and Consulting's online training program. Today we'll answer the question, what is a binomial distribution and what is it used for? There you go. Remember, we do offer ASQ certification preparation classes, and we've been doing it for 20 years. We've become very good at it. So please keep us in mind for all your certification preparation needs. Now, back to the question, what is a binomial distribution? A binomial distribution, first of all, it's a discrete distribution, meaning it doesn't go on forever. That's why we call it discrete. It could also be called non-continuous. Remember, in distributions, we have continuous and non-continuous. We call non-continuous discrete distributions. Discrete distributions is created from attribute type data. What's attribute type data? Has two options, such as pass and fail, which we'll use in our example. So the key words for the binomial distribution, it is used to model defectives. Defectives is the key word. Now, what is a defective? A defective is a part that violated a spec limit. So it violated the spec limit, you usually have to scrap it or rework it, something like that. So keep in mind, binomial is for defectives, which means what? Violated a spec limit. It's not defects. Defectives and defects oftentimes are used interchangeably, but they shouldn't be. Defectives violated a spec limit. Defects is a flaw. They use different distributions. But the binomial, the key word is defectives. And also the binomial must have equal probability between events. Probabilities cannot change between events, which means you either have to have a very large sample size so that if you pick one out and throw it away, it won't really hurt the probabilities at all. Or you must have sampling with replacement for the binomial distribution. Okay, so let's read this question. See if you can pick up on this, that this demands a binomial distribution. A random sample of 20 units is taken from a steady output of product from an oven. Steady output of a product suggests the population is huge, mass production, okay? So that's good. That means we can sample, and even if we don't put it back, replace it, it will still, the sample size is so big, the probabilities aren't going to change significantly. Okay, past experience has shown 7% defective parts. There's the key word, two key elements. Steady output of product, odds are constant, and defective, meaning bad parts. 7% defective parts. That's how I know to use the binomial distribution on this problem. Find the probability of exactly two bad parts. Okay? Use the binomial distribution as we mentioned. And this is the formula. This is another way of stating it right here. This is the combination formula, but usually they put it in this format. So I did that. N equals 20. Where did that come from? 20. Sample size of 20. R is 2, because I'm finding probability of exactly two bad parts. Remember, bad parts, defective mean the same thing. And the percent defective parts was 7%. In this formula, don't use 7%. You'll use 0.07, the proportion. Okay? So we did that. We plugged it in here, did our calculations, and we get 0.252 or 25.2% probability that out of 20 units, 7% defective on average. What's my probability of getting 2? It's 25.2%. Let's do another problem, only let's not use the mathematical equation. Let's use the tables instead. A random sample of 10 units is taken from a steady output of product from an oven. Okay, a big population, that's good for binomial, because whether you sample with replacement or not, the binomial assumption should hold true for us. Past experience has shown 5% defective parts. Find the probability of exactly two bad parts. So there I wrote down everything I need. N equals 10. P bar equals 5% or 0.05 is what we'll use. And find the probability of exactly two parts. Sometimes they call that X and sometimes they call it R. So I thought I'd use both so you could realize there's R. Some books call it X. I don't care what you call it as long as you know what it is. Now, let's go to the table. First thing you have to do in the table, you have to find the table for that sample size. Sample size of 10, there you have it. Then I take my proportion, average proportion defective, and that's 0.05. Remember, I called it average proportion defective, but I could just as well call it average proportion of bad parts. Bad parts and defective mean the same thing. Okay, and there's my x equal 2, where the number 2 row intersects the 0.05 column. That's my probability there, 7.5%. So using the table is pretty quick and easy, and I like using the tables. There's less likelihood of hitting the wrong button as you calculate that. All right, and that's the binomial distribution. Hopefully you learned something that will help you in your career. Remember, keep us in mind should you ever need any ASQ certification preparation training. Thank you very much and have a great day. Goodbye.